Okay, so let's talk about density. So, density is a physical property of a substance. It's also an intensive property. Remember what an intensive property is. It means it's independent of the amount of substance that you have. And it is specific to each substance. So all substances have a different density. So water, for example, liquid water, has a density of 1.00 grams per milliliter. This is an approximation. The density of water actually changes at different temperatures, so this is just to get a rough idea. But density is a relationship between mass and volume. Mass in grams and volume usually in milliliters, but it's always some unit of mass and some unit of volume. Sometimes in lab, you'll see it written as density is in grams per centimeters cubed. Centimeters cubed is also a volume, and 1 centimeter cubed equals 1 milliliter. So it's actually the same thing, but sometimes you see the units written a little differently. Depending on what type of science you're talking about, you would see density recorded differently. Probably in physics classes, when you're talking about volumes of shapes and densities there, you would see it with a volume of centimeters cubed. In chemistry, when we're talking about solutions or even solids, we most of the time use milliliters. It's always a relationship between mass and volume. Grams per milliliter is definitely the unit that we will use most of the time, but it does not have to be that. Okay, so let's say I want you to calculate the density of fool's gold. So calculate the density of fool's gold that has a mass of 25.392 grams and a volume of, let's say, 5.28 milliliters. So we're going to calculate the density of fool's gold that has a mass of 25.392 grams and a volume of 5.28 milliliters. So the formula for density is density equals mass over volume. So D stands for density, M is mass, V is volume. Density equals mass over volume. So to solve for the density of fool's gold, I'm going to take the mass of fool's gold and I'm going to divide by the volume of this piece of fool's gold. And my unit is going to be grams per milliliter. So let's just do that. Density equals mass, 25.392 grams, divided by volume, 5.28 milliliters. And we'll say 25.392 divided by 5.28. We're going to get 4.8090909 grams per milliliter. So if this was a question on an exam and you gave me this answer, you would lose a point, because even though the math is right and the unit is right, the number of significant figures is not right. every time you do a calculation in chemistry, you must report the answer with the correct number of significant figures. This number, 25.392, has 5 significant figures. This number here has 3 significant figures. This is a multiplication or division problem, so we're going to use the rule that says the answer should have the same number of significant figures as the fewest number of significant figures in the problem. My answer should have 3 significant figures. 1, 2, 3. Look at the next digit. It is 5 or higher, so I'm going to round up. So the most correct, completely correct answer to this problem is 4.81 grams per milliliter. That is the density of this piece of fool's gold. So that's how you calculate density. You're given a mass, you're given a volume, you can solve for density. You also, if you're given so there's 3 pieces of information here. If you're given the density and the mass, you could solve for the volume, or if you're given the density and the volume, you could solve for the mass, just based on how you set up your formula. There's something else that I want to draw your attention to, because we're going to see this over and over and over in chemistry, is when you have a unit that has 2 units in it, we will use that as a conversion factor. So anytime you have 2 units in your unit, that means we can use it as a conversion factor. That means you can use it to convert between these 2 units. Convert between, in this case, grams and milliliters, or milliliters and grams, either way. So 4.81 grams per milliliter. Anytime you have a unit with 2 units in it, that means you can use it as a conversion factor. So let's look at an example where we use the density that we just calculated as a conversion factor. So let's say, what is the mass of a piece of fool's gold? And I'm just going to put the density here because we just calculated it, 4.18 grams per milliliter. That occupies, let's say 45.329 milliliters of space. So a volume, that's how much space something occupies. So what is the mass? So I'm solving for mass. I don't know what the mass is. Of a piece of fool's gold, you're given the density. Density equals 4.81 grams per milliliter, and you're given the volume. Volume equals 45.329 milliliters. So, what is the mass? So this was a calculated number that we used from these 2 measured numbers. This is a measured number. So I know my answer should have 3 significant figures. And this is different than some other conversion factors we'll talk about, because we do use the number of significant figures here because we calculated it from these measured numbers. We want to solve for mass. So I can use the density to convert between volume and mass. You also could just rearrange this equation, but we're going to see some more complicated versions of this later where this won't work. So I start with what I'm given. Let's just say 45.329 milliliters. And this is called the railroad method that your textbook uses. I will use this because it's what your textbook uses. You do not have to use this. You could also just rearrange this equation and you would get the exact same answer. So this is what I'm starting with. This is the volume. I'm going to use this density as a conversion factor. I want my units of milliliters to cancel. Here I have milliliters on the top, so I'm going to put milliliters on the bottom so they'll cancel. and I want grams on the top, grams per milliliter. 4.81 grams in 1 milliliter. That's what this means. 4.81 grams per milliliter, 4.81 grams in 1 milliliter. Now I've set it up so that my milliliters will cancel, and I'm just going to multiply across. The way that this railroad method works is you multiply across the top, you multiply across the bottom, you divide the top by the bottom. This is only a one-step calculation. Pretty soon we'll get to some 5 or 6 step calculations where you'll see that this will be a lot more useful. So I'm going to say 45.329 times 4.81 divided by 1. Again, my answer should have 3 significant figures, so I'm going to say 218. And my unit will be given from what's left in this table. Milliliters on the top, milliliters on the bottom cancel. Grams are left. That means the mass of this piece of fool's gold that takes up 45.329 milliliters of space would be 218 grams. So these are some examples with calculations using density. Again, density is always a relationship between mass and volume. It does not have to be grams per milliliter. That's what we will most commonly use. And anytime you see a unit like density that has 2 units in it, be aware that you can use it as a conversion factor. And we'll do a lot more of these later.